In this last portion of Experiment 12, we examine the subject of buffers, a topic of tremendous importance to students who are studying biological sciences. We define a buffer as a solution which resists change to its pH. When I say it resists change, what that means is when acid or base is added to the solution, the pH will only change slightly, typically by less than 1. To make a buffer, we mix a weak acid with its conjugate base, usually as a sodium salt. So let me give you a few examples. Acetic acid is a common weak acid. Its sodium salt is named sodium acetate. That is acetic acid minus a proton, but with a sodium in its place. So sodium acetate. Formic acid, which is the acid which is found in ant bites, is mixed with sodium formate to form a buffer. Citric acid, which, as you might guess from the name, comes from lemons and oranges, can be mixed with sodium citrate to form a buffer. Would a mixture of nitric acid and sodium nitrate produce a buffer? Well, sodium nitrate is the conjugate base of nitric acid, but nitric acid is a strong acid, not a weak acid. Therefore, I would not expect a mixture of nitric acid and sodium nitrate to make a buffer, only a mixture of weak acids with their sodium salts. Now, let's explore why a buffer works. Let's say we have a buffer solution. If we add a base to it, the base will immediately react with the weak acid which is present in the buffer. And what that does is it takes away some of the weak acid and forms more of the conjugate base. At the end of the process, you have weak acid mixed still with conjugate base. On the other hand, if I add an acid to a buffer, it reacts with the conjugate base, which was that sodium salt, and that makes more of the weak acid. So at the end of the process, I still have some conjugate base left over, assuming I didn't add too much acid, and I have more weak acid. But since I still have both of them together in the solution, I still have a buffer solution, and that will continue to resist pH so long as both compounds, the conjugate base and the weak acid, are present in the solution. So adding acid or adding base simply shifts the amount of the weak acid or its conjugate base that we have in the solution, but we still have both parts. Now, if we add too much acid or too much base, that will have cause a problem in that it will completely exhaust one part or the other. For example, if I add too much base, that will react with all of the weak acid and leave only the conjugate base in solution. I will no longer have a buffer. So there is a limit to the amount of acid and base you can add, and we call that the buffer capacity of the solution. We're not going to explore that in any great detail in this class. So getting into part C, what you're going to see is I will take 4 compounds or solutions, and I will see how adding acid in the first part and adding base in the second part causes the pH to change. So those 4 solutions or compounds will be water, 0.1 molar sodium chloride solution, the pH 2 buffer, and the pH 11 buffer. Now, it should be obvious from the name that 2 of these are buffers, but we don't know just yet if water is a buffer, although you could probably make a very good guess about that. And you probably don't know if sodium chloride is going to create a buffer. So what we are going to do is we will test those solutions and see if those act as buffers or not. For a buffered solution, we would expect the pH to change by only a very small amount. And for the purpose of this experiment, let's say by no more than 0.5. So if the pH goes up by less than 0.5 or it goes down by less than 0.5 when we add acid or base, we're going to call that a buffer. For an unbuffered solution, on the other hand, adding acid or base should cause the pH to swing dramatically. For example, if I take a solution with pH 6, which is unbuffered, and add acid, the pH might shift all the way down to 2. And that would be a change of -4. Right? We ended at 2, we started at 6, so the pH has changed by -4. It went down by 4. Take a look at the report sheet on page 141. Now, the experiment tells me I can use cabbage juice or I can use the pH meter. I'm going to use the pH meter for this part of the experiment. It'll be much easier for you to record the values. I want you to round all pH readings to the 10th place. That includes any calculations you make in this part of the experiment. I want you to round everything to the 10th place. In column 1, just write down the pH that you see on the pH meter when we begin. In column 2, write down the pH value after about 5 drops of hydrochloric acid are added in the first part, or in the second part of the experiment, we add sodium hydroxide, base, instead. And again, round to the 10th place. Don't worry if the values are going up and down a little. Just round to the 10th place and you'll be fine. I will add yet another 5 drops of acid in the first part, or base in the second part, for a total of 10 drops. After that's done, you'll want to write down the pH again. And in column 4, it asks for the pH change. So for the pH change, just write the final pH, that's column 3, minus the starting pH, that's column 1. If the pH goes down, it will be a negative number. If it goes up, it will be a positive number. The most important thing is the magnitude of that. If the pH changes by more than +1 or becomes more negative than -1, then that would be a non-buffered, unbuffered solution. On the other hand, if the pH changes by less than 1 either way, you're to go ahead and consider that to be a buffered solution. I'm only going to provide limited narration from here on out. What you will see is a call out indicating what liquid we are testing. In this case, it's water. Then I will add 5 drops of acid, hydrochloric acid specifically in this case. I will swirl it, and you'll see a note on the screen indicating that 5 drops of HCl have been added and that you should record the pH. And then I will add the next 5 drops of acid. And you'll see another note on the screen indicating that that is the value you should write down after 10 drops have been added. So for the acid drops, you will see video for all of this. For the second part, I've elected to put up pictures instead. So this is the 0.1 molar sodium chloride, and in a moment you will see the acid being dropped and labels indicating how much have been added, and then you will see the next 5 drops of acid being dropped into the solution.